So they established an office here, and they're closing the office, and they're moving everybody to
So she should talk to a broker to really get the business together.
I know a lot of Chinese guys.
Is there anything you recommend? No, she just got her. So she needs to get, she's actually just getting looking to get funding from the center.
Rich Hando?
I'll have her call. I'll give you a call ahead.
There this row just to make it a little cozier around here.
What she wanted to do was really get an estimate so she could put that into the financial plan. So the location comes into play as well. Okay, so you should have an idea of the location. Oh no, no, sorry. So you were saying? Sorry. Gotcha. Wow. Okay, so she'll definitely have to get some details sorted out because she can't really get an estimate until she has some details figured out, right? No, not at the moment. She's kind of quite a bit of ways from there, so I will just help. So, okay. Cool. Once she's ready, I'll definitely give you a call for that. Or do you have some, like, if you want to email me some now that you have, I can just forward them to her. So, because she might be calling to get an estimate or something, but I don't know what that's going to be, but that's in the future. So. Cool. So I think this is really good info. Thanks, Lisa. It's perfect. So, and then just the 3% inflation. Just with financial models in general, is that kind of standard, or is that real specific? Because there's one model that's the consultant she has done 1%, a general 1% inflation rate. What's your take on that percentage? Really? Wow. Oh wow. Okay, got you. What? 1 and 2%. So for some reason, I get the impression that it's also just sold on some BS. Right. Right. Square foot per employee. Is there like the space for the people the size of the employees? It's like 100 square feet. How do people think about that number? Oh, really? Okay. Check. Right. Right.
Hello. Hey guys, if you don't mind, please take a seat. We're going to start off.
Oh, French is another issue, right? Right. Okay. Perfect. Well, I gotta run into something. Thank you so much. It was absolutely global. Thank you so much. Appreciate it. Bye bye.
So thanks for coming down. It's the second one of these. We will have many more of the big data user groups. I'm sure if you already signed up for the big data user groups on the meetup, you have probably seen the several talks coming. On July 9th, we have a Cassandra talk. July 16th, we have a Spark talk. On August 6th, we have a real-time and memory Hadoop talk. And August 13th, we have an HBase talk. Other than that, we have Big Data Camp LA. I mean, I'm really excited about that. I know I am. So it's going to be a big event. We're expecting about 400 people. A lot of great sponsors, a lot of great talks, 3 tracks, Hadoop, NoSQL, data science. You guys should sign up. We're going to have a networking event. It's completely free for you guys. So please do sign up. Come and learn about big data, learn about the different tools and different use case scenarios of different industries and different companies. It's going to be amazing. We're going to be putting out the speaker list, I think, by next week. Other than that, I just want to introduce some of the sponsors for tonight's event. I want to thank them for hosting and sponsoring the event. So first we have Blair from Cross Campus to come and do the talk over there.
Thanks very much. I'm Blair, I'm the general manager here. As we are new in this location, we're always interested to see how many people have been here before. Okay, good, 3/4 of you, right on. All right, well then, you guys know, and for those of you who are here for your first time, you know now, we are not just an event venue, although we love putting on some of the best tech events in Silicon Beach. By day and alongside here right now, you can see that we're also a collaborative workspace. People are growing their businesses out here. Startup teams of 2 up to 10 are working here in the satellite offices. We love Big Data Group because we've got a lot of big data projects going on here in our member companies. If you become a member, there'll be a lot of people to bounce ideas off. Anyhow, thanks so much for being here, and have a great event tonight.
Thanks, Dan, Cross Campus for hosting the event. I would like to invite Steve and Sam from Big Data, their location sponsors for today, to come and talk with you.
Good evening, everybody. I am Steve, and this is my partner Sam. And we have a company called Big BIGG Data. And what it is, it's a Hadoop training center. Our first location is opened in the San Fernando Valley, and we've already had a couple of classes come and go. Trained had a few good classes, trained a bunch of people to learn Hadoop. So if you're interested in learning about Hadoop development or Hadoop administration, we've got a couple of centers. Well, one center open now, and we're going to be opening up a second center in Santa Monica probably by the middle of the summer. So I want to thank you all for coming, and here's Sam.
Well, hello everybody, my name is Sam Gower. I'm a co-founder, and obviously Steve is my partner. I just want to thank you all for coming, and I want to thank Subhash for inviting us. It's a great opportunity, and thank you very much to Los Angeles Big Data User Group. And like Steve was mentioning, this is a great opportunity for people who want to know more about Hadoop, who want to learn Hadoop development, administration. Go look us up on the website, and if you wish to enroll, you're more welcome. Thank you, guys.
Thanks, Big Data, for sponsoring. Finally, I want to invite Caroline from Kubernetes. There are 4 main sponsors for tonight.
Hey everybody, I'm Carolyn. I'm from Q. We brought the food and drinks for you tonight. I hope you like it. I just want to tell you a little bit about us real quick, and then we'll go ahead and get started. So Q is a local IT and digital talent firm. Fancy way to say we're recruiters. So if anybody has any need for you're looking for a job, you know someone that's looking, you just want to get a general read on the market, maybe you're looking to hire for your company, anything like that, even if it's just down to help with your resume. We're always happy to help. We give back to our community a lot by sponsoring meetups like this. Quick plug for my meetup called Linux LA, meetup.com/Linux LA, check it out. And with that, I'll hand it off to Subhash. Thanks.
So finally, in this Jan from Rubicon Project, he leads the company's architecture group at Rubicon. They also build the scalable and pluggable inventory and architecture for Rubicon. So tonight, Jan is going to be talking about what is the big idea of about Zookeeper. How many of you over here know what Zookeeper is? Perfect, that's awesome. So Jan, I think you have your talk or workshop for you. You want to explain it?
That's awesome.
All right.
All right, I'm done. No. So, you all see that? Okay. Let me talk a little bit. So I did that first intro, so I don't have to talk marketing material more. So Rubicon, when I started in 2010, was about 40 servers doing 1 billion impressions a day. Today, we built out a global stack of close to 3,000 servers, and we're kind of specialized on sort of small packet, lots of transactions. So we'll dig into that deeper. First, I wanted to mention a little bit about myself. So this is me. If you can see anything, it's going to be horrible in terminal. So this is me trying to find some Lisp at Blarney Stone a couple of weeks back. And if anybody's good at Lisp, you can see what's going on there. I thought it was kind of funny because we're all doing time sharing today, and John McCartney that was kind of what he did back in the day. Since we're all on cloud platforms, and soon we'll have the Hadoop platform that we're sharing as well. So let me talk a little bit about Rubicon. So we're this transaction platform that we basically live on a huge number of transactions. From
marketing standpoint, it's all about automation. The easiest way to think about it is like when you go to Orbis.com or Hotel.com and you get all these pre-made options on your screen, that's kind of what we're doing for the advertising industry. So people have their media plans and so forth still, but they're moving more against automation that, especially in the publication area, they need to because they want to drive down cost and make sure that they get maximum revenue out of it. So we're not an ad company and we're not a publisher. So we basically take these transactions and we auction them out in the back end to a fairly large number of people who wants to bid on these impressions. So we manage both sides of this whole deal, and that's why it says sellers and buyers in the slide. So I've actually been around since Deck Research and Alta Vista. So I built my first data center at the GIX in Sweden in 1997. We got 300,000 hits on GS160. After that, I spent quite some time working with storage for Alta Vista, and then I moved to Yahoo and wrote software there for them for 6 years. We're a MapR shop, so I'm going to probably talk a little bit more skewed towards them because I know them better. But this talk is specifically going to be about Zookeeper that most of these systems use anyway. And this is our latest benchmark. So we did a terabyte in around 4 minutes on a sort of untweaked system. So let's spend a little bit of time on this. So if you want to build like a 100-node cluster of Hadoop, this is kind of my recommendations about it, and it tells a little bit about what we do. So we get about 50 terabytes a day in the incoming stream. We're like a spoken hub kind of design, so we have our spokes up on the high connected internet exchanges. So everybody has like really low latency to us. And then all the bidders also have very low latency. So in 80 milliseconds from your browser to a full auction, everything's done. We picked it, we served it, it's done. So given the sort of 100 billion impressions that we do with it, there's a lot of data that needs to go back into our main data center. In our main data center, that's where we have our Hadoop clusters. So this sort of represents the latest one that we built. So there's a few things on this picture I think is worth highlighting. So we use Arista as our 10 gig aggregation switch. We basically do like a large, chassis and just put as much 10 or 40 gig as we can on that thing. And then we, actually I don't like top-of-rack switches, but my ops team is kind of adamant about having them. I like these cassettes where you basically just patch in lots of fiber and get like non-blocking from all the hosts. But maybe next time. So we have the top-of-rack switches they're hooking in. We got a good 80 gig up to these guys. When you build with MapR, there's a few things to think about. So the yellow thing on the top that you can't read is basically the Zookeeper nodes. We'll talk a little bit more about how to set them up or what to think about. But those are basically 3 Zookeeper nodes to take care of all the consistency. Underneath that, I put 6 of the CLB nodes, which is MapR's way of doing redundant info. So they actually, like in 2010 when we were at Cloudera Shop, we were running CDH3. We had a problem that I think a lot of people had with checkpointing and realizing that the secondary name node had nothing to do with secondary. So, we kind of were a little bit worried about that piece. So we went out and tried to just find something that was redundant. And then we hooked up with MapR and they had a redundant solution that we sort of, that looks good, let's go with it. In the meantime, Cloudera's catched up and they have redundant, and so the CDH5 now has pretty good redundancy in terms of what they do. So we have 6 of these CLB nodes that handles all the transaction volume. And then underneath that, we have the job trackers. So we have 3 job trackers on this particular cluster as well. one of the nice things with MapR is the things that I've missed from the Hadoop side is, if you've been in HPC and in high performance computing, you kind of like those POSIX things, right? So you can easily get things in and out. And MapR actually has a pretty decent NFS system on the machines. It kind of works like you set up the nodes inside of the cluster with NFS, and then you can have redundant NFS against it. We actually got some good 450 megabytes a second out of a single node on NFS that we benched it the other day. The other thing about this picture is that it's got the solar flare card on the top left there. We kind of like that card for a few reasons. When I started to dig in on a lot of the 10 gig stuff, it's like you have to tune these cards because the Linux box is really made for gigabit. So when you look at a 10 gig card, I have some Intel early 10 gig cards. They do a few things that are not good. The most prominent one, I think, is because if you don't put the interrupts from the fiber card onto each core, on a dedicated core, you're not going to get any interrupt caching on that core. So they have like scripts that you run on the Intel thing to actually make that happen. Otherwise, you would actually consume CPU that you don't need to consume. And in a Hadoop cluster, that you don't really want to consume CPU things. So we used the solar flares and we benched them again. So we were able to get 9.98 out of each 10 gig that we have. So we're pretty happy with that. We also, of course, saturated all the 80 gig ports. So we know we have a cluster that, from the networking standpoint, we did pretty okay. The machine that's up on the right, there's a few schools here. The ops team really wants to have the job trackers and some of the other nodes on more enterprise class hardware, and I think that's certainly true when it comes to like the Cloudera distribution, and you want to have those redundant because there's a lot of dependencies in those components. In the MapR case, you can, or it's not a bad thing, but you don't have to. So for the majority of these nodes, we actually bought them from a company in Irvine called PSC Labs. What happened was I was looking for a commodity hardware platform that was cheap, but still had 2 sockets for the CPUs, and I could get like at least dual 6 cores on there. So I looked at a bunch of cheap Taiwanese drives, but I couldn't find one with 2 sockets. And then it's got 12 drives on there that has like the straight SATA out to these drives. So from a Hadoop standpoint, this is a pretty neat little box, and I could actually get the cluster organized for not a tremendous amount of money. So I think this cluster is a little bit about 4 petabytes in terms of its size, which is a reasonable size for this type of cluster. So there's a lot of data coming into the cluster, so we kind of depend on NFS to function and to be redundant. We also use a lot of the data that we're gathering to feed other systems. So one of the most obvious one is the Rubicon data warehouse. So we feed that system with data from Hadoop. We also feed all of my SQL clusters, the Druid clusters, all the key value stores, everything that sits in the back of any user interface, because some of them requires very special treatment in terms of what SQL queries or multi-dimensional queries you want to do against them. So we basically do that against those systems. So one of the things that we don't do is that we don't do any big jobs, we don't do any, and we actually use most Java jobs that we build ourselves. I think the reason for that goes back to the earlier slide that I said, they're all a bunch of yahoos, which, we kind of are a bunch of yahoos that are kind of used to writing our Java code. So that's the latest cluster. I think 10 gig gives a lot of lift for Hadoop. We certainly had our fair share of problems on our 1 gig cluster. And I remember the CTO at the time, he said, no, you don't need to bond anything. 1 gig is fine. I'm going to make sure everything stays local on the machine. That was a mistake. The other mistake is that for Zookeeper, you don't really want to have 4 or 6 or 2. You don't want to have an even number of Zookeepers. And you don't want to have the Zookeepers being slow on their network or the CLD nodes, because I'll get into it a little bit later, but Zookeeper is this coordination service that can create like storms of updates that everybody wants to read. All right, so that's the cluster. So a little bit of some other things that's going on in the cluster. So I took this picture. I'm not going to dig into it much today, but in terms of what we do for an exchange, we actually see a lot of the auction data that's traversing our system. We see like 99% of all the creatives that are out on the web. I think it's almost a year now since we have wider spread on display advertising in Google. So in terms of number of uniques, and that's partly because we're focused a lot on premium inventory. So a lot of the big publishers are on our platform. So that way, we have a lot of pricing data. So we use a lot of auction theory on the cluster itself. That's probably a subject for a completely different talk about what we do there. But in very short terms, it's really not about serving the highest paying ad. It's really about exhaustion and make sure that you actually use all your inventory and make sure that the pricing is where both publishers and advertisers or trading desks wants to have. So this market is evolving as people are getting better and better on this. But that's a big part of what we do on So let's go to Zookeeper. So the guy up in the corner to the right is one of my favorites. His name is Mike Burrows. He was one of the guys that started out on this back in the day, 1995. He wrote the interlude for the search engine in Assembler for 64-bit alpha. Pretty smart guy. He's now at Google and went to Google pretty early on. He is basically the guy that made sure that they had the ability to do the big table development. And the reason why they could do that was because he had this idea about Chubby, which is his DNS implementation, which paper was the source for Ben Reed to start writing Zookeeper. So I did talk to Ben Reed before I had this talk, and I said, I hope I'll do you justice. I call you if they have any hard questions. So Ben is at Facebook these days. All right, so let's talk about Zookeeper. So what it is, it's a name service. It has distributed locking. It does synchronization, and you can do dynamic configuration management. DNS is actually not a bad example of what you want to do in a local network, because in a cluster, you're really not interested in waiting for TTLs on things if they're up and down. One thing that we hear a lot is like, well, if you're a bidder on the outside and you're configured with DNS, he might have like machine that's down, and he's telling us the machine is down, but we are actually TTLing on his machine since he's doing the round robin thing. And that would be really nice if you could just flip a switch and it would be gone. And that's kind of what Zookeeper would do for such an application. The thing is also the failover scenario, right? So my favorite quote from the Chubby paper is that he says in the paper, it's like, we often start with prototypes that we develop for clusters, and we have them loosely coupled, and we start prototyping, we write something, and then after that is done, and we're getting a lot of users on the system, we start to think about redundancy and synchronization and making sure that we actually have the right data. I've been in this industry for a long time. I still see that all the time. We're going to be a lot better though, because there was a lot of hands going up at Zookeeper, and Zookeeper is definitely, more prevalent in the systems today than it used to be. So I'm going to pick some use cases that it's easier now that we're a public company to talk about what other people do with Zookeeper than we do. So I don't need to have my marketing manager to approve these slides. I just took them from Pinterest in the public. So Pinterest actually has like some good use cases for Zookeeper. that URL, I'm going to make this available for everybody later on. But I already mentioned, don't wait for TTL. Make sure that your system is redundant and use Zookeeper for it. So if you look what Pinterest has done is that they're actually using it for sharding. So they can actually, in Zookeeper, keep the data where to go for the databases in terms of where it is. Well, we'll take a closer look to Zookeeper and get a better understanding of this later. The other thing that I thought was pretty cool is that they actually are using it to see what services are available on the inside as well. This is more of a traditional load balancer configuration, I would say, but you can certainly do that with Zookeeper as well. But yeah, it's really, really useful. As soon as you have cluster, I can tell you how useful it is in advertising where you have like a lot of machines that need to do a lot of complicated things, and they all need to know about what's available in terms of where things are internally. And we only have these 80 milliseconds to play around with. We actually don't have 80 milliseconds. 80 milliseconds is a whole transit. We have more like 5, 10 milliseconds. And then we start getting into trouble. So we do a lot on the switch side that nobody else knows with. For a different topic. So let's go into Zookeeper and take a little bit of a look on what it looks like. So it has a leader and it has followers. In a three node system, this is what it would look like. And then I actually added an observer on there as well. So one of the things that you need to think about when you do Zookeeper is that it's kind of write heavy. So you want to have a system that can handle a lot of writes. So if you have a large cluster and you want to go with like 5 or more Zookeepers, you need to be careful because now you're actually expanding the time it takes for election because now you have more people that needs to write this data. So you're actually better off if you put observers on there. Observers are not able to elect, but they will take all the transits that is happening in terms of the Zookeeper nodes. The other thing that this slide kind of is highlighting is the way that Zookeeper is set up, which is it's its own election mechanism. So a lot of people know maybe about Paxos and how that works. So Zookeeper is using something called ZAB, and we'll dig into that a little bit deeper. But you have the common terms here is basically you have an observer, you have an ensemble, which is the leaders and the followers, and you have a core once you have everybody that needs to be there. So let's take a look at ZAB. So it's different than Paxos. So Paxos, at least to me, is more of a state machine application mechanism because things can actually be handled out of order. Zookeeper is very, very adamant about these writes being in the right order. So when the leader who is responsible for giving the stamp on the transaction makes the sort of preface commit itself and goes out and talks to its followers and see, here's the commit, we need to do it. They come back and say like, okay, we're good. It basically goes in and everybody commits that change. If that's not good, it has a full rollback because it kind of has this right ahead log. So again, it's a really small database made for small things. Each node can only be like a meg, but it does it really, really effectively. A single node can do like 50,000 transactions easily. All right. So this is just, I put this in here because I wanted to highlight the fact that Zookeeper is actually doing linearizable writes, which gives it a good consistency and the transactions are really there. And then it does a serializable read. So you can actually get stale content if you're in a weird situation on your Zookeeper where you don't have the latest information. But that's okay, because you're not going to do a commit until the other guys are actually agreeing that it's okay. But there's a difference between this. I'm not going to dig into it too deeply, I think, with this crowd. All right, so I talked a little bit about the gotchas. So some of them are kind of obvious. Don't use it for a database. It's not meant for that. You can't have a lot of data in there. It's not effective. You want to have good disk write performance. I really just do a single disk or maybe a RAID one. That's about it. And it has its own machines in our clusters. We can separate them out. If you're using a RAID, make sure you have a battery backup because you don't want to lose that piece, and you don't want to sit and wait for RAID rebuilds because then Zookeeper can actually time out just because you're rebuilding the RAID. You also don't want to have message delays on the network. So in a poor configured network where you basically have constraints, you might get out of order just by the fact that the network is not functioning properly. Then you might also have NTP misconfigured and drift inside of your cluster. You really don't want to have that. It might just kill you. You don't either want to have different processors. So don't scavenge machines for your Zookeepers. They need to be like the same boxes. Yeah, that one is kind of obvious. Go to pages is just a highlight from my side. It's like you don't want to have it set too high because that is going to impact your web speed. And make sure you have odd numbers. So I guess I should explain that a little bit. So if you have a cluster with 5 nodes versus a cluster with 4 nodes. A cluster with 5 nodes means that you basically have, as soon as you have 3, you're going to have a quorum to be able to do a commit. So you can lose 2. If you have 4, you can really only lose 1. So it gives impact on how redundant your Zookeeper cluster is. But nobody's really proven this yet, but I've seen it that a 4 or a 6 cluster might actually take a little bit longer to read because it has other mechanisms inside of Zookeeper when it's getting like this even vote to go back. Paxos, by the way, doesn't really have this kind of problem. You will see Paxos in a lot of proprietary systems as well. I think Aerospike is running and it's actually using Paxos. So let's dig into a Z-node. The way I think about a Z-node is just directory structure. So it lives in RAM on Zookeeper. You can browse it, and it's got some simple command. So there's a very few types of what you can do inside of this tree. So you can have persistence settings, something that's going to be there all the time, or you have an ephemeral node, which by the time it disappears, that section will just go away, and we'll see that. And then you can have persistent sequential and ephemeral sequential, which is just counting up, but I'm not going to use that. So it's very, very easy to install. On the installation I have here, I just took like the tarball actually from the Zookeeper side, and I put it into my own directory here, and basically had a few things in the configuration file. One thing to think about here is just tick time. Tick time is basically its internal round trip time. So you can set it to whatever value, but init limit and sync limit will depend on it. So init limit is how long time it's going to wait for any node to actually initialize with Zookeeper before it says that it's unavailable. And then the sync limit is how long time it's going to take to synchronize. Let's see if I missed anything on that one. It's a little bit different depending on which version of Zookeeper you download. I think I'm running like 2.4.5 on this guy, which actually has a little bit different commands than the previous versions that are a little bit more common out there. But yeah, so you can see I kind of wrote up to see how you calculate the 20 seconds and the 10 seconds depending on the tick time times the init limit or the sync limit. So a few things about the Zookeeper API. So it's weight free. So, I mean, you can see that it's really made for having a persistent state on your cluster, right? And it's got no deadlocking. Again, like if you have like something that needs to, let's say you have a two-stage system where you have some sort of server that needs to talk to a bunch of subcomponents, doesn't matter what they are, you can maintain the state in Zookeeper and you will always know who's available underneath. And that's kind of how it's getting used in Hadoop as well. You basically, if you log on to Hadoop, you will see all your nodes in that directory tree. You will also see what locks you have. And it is extremely fast, and it's not consuming much resources on the machine. The reason you put it out on your own machine is not because it's heavy in any sense. It's more that you don't want these writes to be suffering from anything else going on. So we put them together with other systems in the past, and lately we decided, okay, let's just give them their own hosts. It's not that expensive to get these kinds of hosts going, but they are really benefiting from being separated out. All right, here's all the API calls. You can probably read this by yourself. You can basically get the set values. Some of the new stuff is that you can get children on a C node as well. Multi-operations that you can do, and sending like a whole slew of operations also new. And then if you take a look at this, you can see how simple this is, right? It's not very complicated. And that's kind of the beauty in terms of the APIs. All right, so I'm going to have a few machines here, so I'm going to hope that you actually can see what's on the screen. It looks like it's getting better. So I have 3 nodes, which is my ensemble, and then the Boga there is just my sort of control node that I'm using. So here's my 3 nodes. Here's frac 1, here's frac 2, here's frac 3. The back there should probably have Boga. This is even readable. So, all right, so we can see that, I'm not sure, I think things are probably up and running here. Let's take a look at these guys. So yeah, we have a leader. We'll make that a bit bigger. So yeah, we have a leader on 2181. And then we have 2 followers on this particular setup. So let me hook up to one of these guys. Oops. All right, so this is just using the command line CLI. It actually works pretty badly between versions, so you need to be careful which version you're actually running when you're using it. But this is what the C node looks like, right? So it's right now I just have like a Zookeeper C node in there, and there is a config quota. I can of course just create a C node here, and I'm just going to call it 1. So I created a master. So let's look at master. So I can do get master. And it's got yawn. So now any one of these nodes, of course, is going to be able to see the same thing on this master entry that I created. So if I want to create the listener on master, it's actually fairly easy. I can just or a watcher. So this is how you create the watcher now. Now I'm going to watch for events on that master entry. Like just sound it. Okay. All right, so this portion of this is going to be a little bit interesting. So let's go back to the slide. I've tried this one before, and I completely confused everybody. So I'll try it again. I'm going to delete that guy first. Okay, so now I saw that since I deleted the mask, I get a notification saying that it got deleted. So now Zookeeper is empty. So what I wanted to go through is basically a little exercise here where you basically have a master that is watching for workers and basically assigns tasks to them. And then you have a bunch of workers. So this would be a good example of if you have like a contention that you want to maintain in terms of how many tasks can be assigned to something. The master would be the guy that actually gives this out to the workers. And the client is the guy that actually assigns, he needs to get something done, right? So we'll see how this goes. So it can be a little bit confusing to follow, but we'll give it a shot. So I'm going to change column on this guy. I'm going to be client here. There we go. Client. We're going to be a worker in this window. So I have a worker. And this guy is going to be the, let's see. He's going to be the master. So, there we go. So first of all, I need to create some entries here. So I need to create the worker space. So I create workers. And then I create tasks. So these are just C nodes that I get created. All right, so now in Zookeeper we have assigned, and we have tasks, and we have workers. So if I then go to the master node, the master needs to check for workers to see if there's actually any workers changing their status in the workers directory. Oops, I need to connect first. All right, so now I'm going to put the watcher on workers, and I'm going to put the watcher on tasks. So that's the two things that I'm interested in. Okay, so now the master is going to be notified if something happens in workers and if something happens in tasks. Now let's move on to the worker. So that doesn't matter. We can start things here. Oh. Okay. So the worker needs to basically say that it's available to take tasks. So it's going to create itself as an ephemeral node, which means that if this worker were to disappear before it actually completes the tasks, everybody's going to, or the people who are watching is going to get notified, and this, what the worker does in the ephemeral node will disappear out of the C node tree. So let's create workers. I'm going to call myself, I'm going to create something called worker 1, which is this guy, and then worker 1 has a port number associated with it, so let's say 484. Oops. 8-E. E for ephemeral. So all right, there we go. So I created an ephemeral node, so where I could disappear now, that thing is just going to disappear. So we should have gotten a notification in the master window, which is back here, because he's watching the workers directory, and he says like, okay, here's the event, right? So I got a node children changed in path workers. So let's go back to worker for a second. He needs to create a parental node for receiving assignments, right? So we're going to create a assign for worker 1, and we're going to leave empty. And that's going to be persistent. So, and then let's see if somebody's going to assign anything to us, right? So I'm going to put a watcher on the assignment here for worker 1. So now I'm watching my incoming. All right, so now we can go to the client and see if we can get the client up and running. Center. I keep forgetting the names. This is client. All right, so we're connected. So he wants to add a task to the system. So he's going to create the task, which has a sequential iteration on it, so we can add more. In tasks, and then task dash, which is how you create these. I'm going to tell whoever takes this task to update the database. All right. So now I created a task, and again, the master is watching, so he's now getting that something changed in tasks as well. So depending on the logic and the worker and so forth, you are now getting pretty close to getting something done. All right, the other thing that the client wants to do is he wants to watch to see that this task is completed, right? So he wants to put a watcher on tasks and the task that he created, which is this guy. So now he gets notified if somebody actually is doing something with this task. All right, so now we can go to the master, and he can check in tasks to see where because he got notified, and what's going on there. Okay, so there's a task. Now let's see if I have any workers, right? So, yep, I do have a worker, so I have worker 1. And now we can actually assign this task to this worker. So assign to worker 1 and task, and then we're going to have a bunch of series here. And I'm going to tell this worker that you do not have a lot of time. You have this delay of like 80 milliseconds. So, all right, I'm going to create that task. So or assignment task, right? So now the task is assigned, and we should have a notification in the worker window here saying, there's somebody that assigned a task to me, worker 1. So, the worker can now go and get the task. So we can get the value on assign worker 1. Oops. Okay, so there's a task there for me that says something else like so now I'm going to pick up the task, I'm going to do my stuff, and then I need to change the status of this thing. So now I'm done. I've done all of my logic. So I can create a task in tasks. Let's see. Tasks. All right, and I created it as a status. Done. All right, so I took up the task, I did my work, and it's now done. So the client, at this point in time, got a notification that the task has changed in tasks, and the task with log zeros. So he can get tasks, and task log zeros, and you can get status. So it says done. So now, the client can go in and delete all, or delete that task. I'm just going to delete all tasks. So now we actually went through this whole exercise of having a master that will handle the workers and make sure that he's handling out the tasks. So we have a client that can actually just assign stuff inside of Zookeeper. And it'll keep it lock-free, and it'll keep the things in order, and it will take care of things going up and down inside of your cluster. So again, now that you see this, it might be a little bit easier to see what Pinterest did with their stuff, because it is really powerful in a lot of ways to maintain consistency and even handle simpler things like this. And again, if we were to it looks a little bit messy. I was planning to hook up to our map our cluster internally, but the VPN client is spewing out a lot of timeout errors in the client, so you can't actually see it. But you would see all the nodes in there that are off. And this is what Mike Burrows was thinking when he were first to install Shelter. It's like, I'm not going to wait for SLAs or time to live on my servers inside. I need to know what's up and what's down, and they need to, be able to affect it immediately, right? So it is much more powerful than anything that has to do with TTLs. All right, so let's move on to Zookeeper a little bit deeper. So Zookeeper is kind of the old school consensus mechanism to use. It's been around for a little while these days. The core component of Zookeeper is really you saw all the handles that I use when I have my watchers on the C nodes. That is really one of the most powerful things. To be notified when something changed that I'm watching, and basically get a callback for that function. So, and the handle, we're going to take a look at the handles since it's such a core component, but you can understand as soon as you are using the handle and you get all these statuses, you have a lot of code that you need to write to be actually doing all the stuff that Zookeeper is supposed to do. I'm touching on the surface here of a lot of things. But here's what the handle looks like, right? So it is pretty straightforward. So you have your connect string, which has the host name and the port for the Zookeeper servers, and then you have your session timeout, which is like if you set it to 15,000, it's going to be 15 seconds, and then you have your object, which is the watcher, right? And you need to create that to be able to see events happening, right? So, here's the watcher interface. If you take a look at this, you need to monitor the health of the session with Zookeeper. So, if you have anything expiring or something, you need to notify, right? So we're getting close to the portion here, which is kind of always a little bit interesting. So let's play a little bit with this watcher thing. So I'm going to go over to my controller here, and I'm going to put that to this, and then I'm just going to create that single directory. All right, so I'm a new user. So let's create a master Java thing that's going to use the handle, right? So first, let's import some Zookeeper stuff. So org Apache Zookeeper, and then we need, of course, Zookeeper itself. Then we should also have Apache Zookeeper. Oops. Watcher. And then we should have the watched event. Okay, so far so good. Now let's start this with creating a public class of implement master, and then implement watcher. Okay, so create Zookeeper. Okay, let's do. Oops. Okay, so now we need to create the constructor here. So let's do. I pretty much stole this from Benjamin anyways. So, oops. Do the right thing. So setting up the support. Right thing to it. So now I need to create like the Zookeeper object. It's always hard to type in front of the big audience like this. I keep myself in sync. So we're gonna create the Zookeeper object using the master object as the watcher callback. So start Zookeeper, and that throws section. And then create the new Zookeeper here. So there we go. And then, as you saw earlier, there's a host port. Oops. And there's a timeout, so it says to 1500 in this case. And it should be all we need there. If you see anything I missed, just call. So in the constructor, we don't actually associate the Zookeeper object. This is something to do with like the Java best practices in this particular case. So now we can go on and create the sort of watched event over here. So we do a public void on process watched event. There we go. And E. And then start that thing. So I'm not going to do any fancy event handling with this guy. So we're just going to print out the event as it happens, right? So we do a system out print alone. So now we should be notified if something happens with this particular piece. All right. All right, let's put the main in there. So well, all right. And now we're doing the master. We create the so it takes the art. Now, we need to put a sleep in here so we don't disappear out of this before anything has happened. So, actually, I need to start it first. I need to start a Zookeeper here. That should be great. So the sleep is basically going to sleep for 60,000. And that should do it. All right, if everything is going according to plan here, I should be in pretty good shape on this guy.
Want to put the name at the name?
Thank you.
Also on the first line of
The first what?
Put that, yeah, at the top there where you're Zookeeper, it should be camel case.
Oh, so let's see.
The very first line underneath your class. Is it the right down? There you go, right down.
Oh, there we go. Okay. All right, we're gonna play it safe here. Yeah, you're right. All right, let's try this and see how it goes.
One word.
One word?
Yeah. A host port.
Oh, yeah, thank you. Whew. All right, let's do this. Oopsie. Let's see here. There's a lot of stuff going on here. Let's switch. Ah, look at that. So we got our little master, right? So now we can actually hook it up to something. So let's hook it up to the Zookeeper node and see what we can do with it. So let's see. So this is actually, like, most of this is just status messages that comes with a handler, but the latest one where it says what's the net state, connected type, blah, blah, blah. That is actually the print that we're getting. So The worker is now hooked up to the Zookeeper node. So so it's basically watching for something that's happening on which node did I hook up to? Was it frac 1? I think so.
Yes.
So we can go to frac 1 over here somewhere. Okay, so this is frac 1. So if we basically go let's do it. So now it's stopped. We might have timed out there. This is where I got it. So we can see what happened now. Now it's tried to reconnect to this guy. So we're basically going to start this guy up. So now you can see that you actually got a sync connected on that guy. So it'll watch for states on this particular Zookeeper node. So this is kind of the essence of the Zookeeper watch mechanisms. So you can see it got an event saying that it stopped, and now it's just trying to connect again. So that's kind of how you implement like a simpler handler for the Zookeeper. So let's go back to this stuff, and let's talk about some other stuff. So when you see this Zookeeper, you realize like how much code you need to write for all these things. So what Netflix did was they wrote something called Curator, which is an easier way to handle Zookeeper. So it actually has a lot of things ready for you. So it has a set of libraries that you can use, and it also has like a whole set of recipes on the website. So it is fairly straightforward to implement something with Zookeeper if you just want to use Curator for it. So it also has a Fluent API. So I wanted to give you an example so you can see how the C node is created in Zookeeper, and you can see how it looks also in the Fluent API when it's a little bit more straightforward. Curator is pretty popular. We haven't done too much with it, but I was pretty impressed when I saw Lincoln's Norbert, because it is Scala. And it wraps Zookeeper as well, but it also has Netty as part of it. And Netty is an interesting little beast. So it actually, like in the latest Zookeeper, I think, Netty is also part of that, of the supported things in there. And, it is basically an asynchronous network-driven system. So, you basically have things already given for you when it comes to TCP and UDP socket development. You can create servers and clients really easily. You have a unified API for various transport types. And you have a highly customizable thread model as well. So you can have the staged event-driven architecture that it's Cassandra is using and those other things. So there's a little show there in terms of how you can actually get like a client service set up with Norbert. I'm actually really dying to test this out, but I thought I'd give you guys a hint about Norbert. And this is how it looks in Scala. So Scala being more and more popular with Spark and Shark, and other systems. The nice thing, I guess, is you actually got a functional language that is using your Java interpreter. So the risk of using now a language like that is much safer than digging into Erlang, which is, I'm Swedish by the way, so Erlang is close to my heart. I mean, Scala is beautiful to read. I mean, take a look at that. It's actually really, really nice. We're pretty excited to start getting this organized. But 3 steps, you basically have you can retrieve. I basically line them out, so you can retrieve the nodes in that CC nodes if you're ready. So this is a little bit more about Zookeeper. So it can do a lot of operations per second. It has everything in memory, and it does atomic writes. So with good order on everything that happens. You don't lose any data in Zookeeper. So I have a bunch of references on a lot of the things that I went through to find a lot of these things. And there's still a lot of digging, even for Rubicon to dig into. But in terms of Zookeeper clusters, I think we have at least 10 different Zookeeper clusters. Some of the more interesting points in Zookeeper is still to do data center replication with Zookeeper, which you can actually use the observer infrastructure to, if you have, let's say you have a Zookeeper cluster in the main data center, and you want to have everything throughout multiple data centers to be replicated in that tree in your C nodes, you basically put observers in the other data centers and have them come back to your main cluster, and you will have everything updated. Now there's lots to think about there because you have latency, and you really have to use observers because you can't have timeouts that is pending because of latency and links. So we're actually in fairly good shape at Rubicon to do something like this. All our data centers are hooked up with full mesh MPLS through botnet these days. So we actually have multiple 10 gigs connecting pretty much everywhere, including Europe. So that's actually kind of a requirement these days because we can't send all the data that we have through VPN connections. It just takes too long time. All right, I'm actually at the end here. There was one thing that I forgot to mention when it comes to our latest cluster. It was actually kind of a long discussion with the ops team about enabling jumbo frames for that cluster. And if you research on the web, there's a lot of different opinions about using them or not using them. It ended up being a really good thing. We haven't actually tried to exhaust all our links without jumbo frames, but we know that we can exhaust the network now that we have that enabled. You just need to be a little bit careful because you don't really want to have to. Most of the switches are kind of okay with handling, jumbo frames and not jumbo frames, and just doing the defragmentation of that. But you still need to be careful about what you do. But it'll definitely help when you traverse a lot of data on long distances to enable just larger sends, right? So if we could use UDP, we would probably do it in those long hauls, but jumbo frames is definitely a key thing here. And we haven't so far seen any implications on the CPUs in our system. So I tried to focus on Zookeeper and giving you guys like a feel for what it is. I realize that some of you might know more than I do about this, but it's such a key component for anybody that wants to do a cluster. I mean, we have actually proprietary systems inside of our data center that people have been developing over time, which has traditional configuration files, but like, oh, here's my other nodes. And every time you need to do something, you need to push out another configuration. We actually use Puppet to push everything out. So all our data centers are lights out. So it's not that hard, but it's still such an unnecessary thing to do because somebody needs to be notified when this node is up or down and push like configuration files. So Zookeeper takes care of all that for you if you implement it in the beginning of the system. And it just has so much potential. And when you talk to Ben Reed about this, he really just optimize something that is really good on reads, and you can do a lot of it, to have these small configurations dynamically changed on you. And it was, I mean, he read the Chubby paper, so that's what he did. But there are actually a few new ones that I've seen, but I haven't tested out, that is also doing this consistency, synchronization and locking. All right, thank you guys. Do you have a question?
Oh, so whoever would like to ask a question, I'll come to you with a mic, and then while your question is being answered, I'll line up the next question. So we just have a nice cycle.
Just a question about you want to use the cluster for multiple purposes for like H-base and so on. When do you decide to have different Zookeeper clusters for different use cases?
How do you decide if you want to have your own Zookeeper or if you want to run it on the host?
Yes, that and also whether for different use cases like platform, H-base and so on. Two completely different use cases.
So our experience with Storm, and again, it might be different from your experience with Storm. We have quite a few Storm clusters. They're normally like 4 or 5 nodes. They have a lot of memory. They have a lot of CPU. So they literally burned out like a few Dell machines that just melted on us. Because we can pretty much use as much CPU as we get on these boxes. The state of the fact of Zookeeper, if you ask me, is that I do not like the RPC call, and it's actually not the most stable platform to have out there. But at the time that we implemented it, it was pretty much the only one that we have. I'll let them run on the same nodes, and so far that hasn't been a problem. So yeah, there hasn't been a requirement to do anything about Zookeeper there, but there's other problems with Storm that we're tackling. And I mean, we're looking at alternatives to Zookeeper at this time as well. And I mean, obviously, because we're in a hard shop, we're trying to understand performance on their M7, which actually is, from a layered structure on M7, it's pretty nice because one of the reasons we went with these guys as well is that HDFS being all Java and written by Cutler, no. But it's like a C version of that you understand is a good starting point, and that Mapr has that with them. And also, if you look at the design here with like lots of networking, the way that Mapr works is that you get like a push in to a volume, right? And then Mapr tries to just spread it out as quickly as possible into the smaller components inside of your cluster. And if that goes really quickly, you have much smaller data that you can operate on, which is like why we want this network to actually have as much throughput as we can, right? Because we know in the old days with Hadoop, we used to count like, okay, so how many cores do I have? So if I have like 8 cores, I want to have a system that has 8 drives. That was kind of the rough rule of thumb to get something going. Mapr is more like, if I have a node, how much bandwidth do I have? So you don't really, like, you care about disks because that gives you capacity, but in terms of bandwidth, it's a very important criteria for Mapr. But I think breaking out Zookeeper, because it's such a lightweight thing, is not expensive, right? You can take the smallest node you have with just 4 drives or whatever, and do like a, very simple setup. And it doesn't require more memory either, right? Because, you can only get like a meg on one of these entry points in the Z nodes. So, break it up quicker than you think you would, right? And it's probably my recommendation, because if you have a system that uses a lot of disk, and now you're getting timeouts in Zookeeper, and your system is using a lot of disk, and you have a leader, that, it's going to take time before it actually says, like, okay, here's a leader, here's something to do, right? That time is super annoying for us, right? Because A, we don't have any milliseconds, and B, the cluster is in this weird state that you read the log files, and there's like thousands and thousands of entries about, timeouts or clocks or what have you, right? So I would just break it up if just showing any indication that it's actually like doing stuff on this. But Storm is an in-memory game, right? So it doesn't use much disks. So, and we normally use like 16 gig sticks seems to be the sweet spot. So I just take machines and just fill them with 16 gig sticks and get a bunch of them. All right.
So this is a question. Do you have any kind of, does Rubicon has any kind of monitoring management software like Netflix Exhibitor to manage Zookeeper? And when a Zookeeper node goes down, what is the process of rebuilding and restoring it?
So one of the nice things that I actually should have shown you guys, there's a directory. When you install the tarball for Zookeeper, there's a directory for Ganglia in there. So you can actually hook this into whatever monitoring system you have. If you're talking about the ops aspect of like replacing a node and that kind of stuff, was that your question? Sorry.
I was asking like if you use like Exhibitor from Netflix or like just Ganglia or JMX to monitor to have like any kind of Zookeeper node?
No, it hasn't been. I mean, the thing will spit out log4j messages like nobody's business. So it's actually probably if you have a system that's in flux, right? It's probably better to see what's going on the C node side and you know there will be messages inside of your log4j that says a little bit more what's going on. But debugging Zookeeper is often a little bit tricky because you have your application on top as well. But we don't use at Rubicon. We don't use more than sort of the monitoring inside of Zookeeper. And then, I mean, again, since we're a MapR customer, we have these guys log on to the system if there is anything really awkward going on. So in terms of Storm, we haven't actually had any problems with Storm and Zookeeper. Another system that uses it, I think, is Druid, and that is also pretty. Druid is actually pretty good. So I'm pretty happy with that.
One quick question. You mentioned that you, at the end, you mentioned that you implemented jumbo frames. What was the driver for implementing jumbo frames? Is it like reducing CPU interrupts, or?
Oh, jumbo frames?
Yeah.
No. So there's a few things. So first of all, the configuration that I saw on the 10 gigs when I started, everything was hands-off, like buffer sizes and all that kind of stuff. And I started to try to get, I couldn't saturate the interfaces to more than 4 gigabit per second. So I was like, okay, how do I tackle this? And one of the things that I wanted to try for a long time was just enabling some jumbo frames for the processor. So I was concerned that we're going to see CPU usage because of a lot of the configs that needs to happen on a 10 gig. But it turns out, like, I think we're using, like, I want to say, like, SF. It's a single port solar flare. But it actually, like, it has all these, when you install it, if you install the driver to solar flare before you install your so we're a CentOS shop, right? So you basically install CentOS 6, you get solar flare support, and then you install your solar flare driver after you install your regular system. Then that driver will update almost all the kernel parameters that you need, plus it will do the coalescing on your IOQs as well. So we actually didn't have to do maybe 1 or 2 tweaks to get it up to fully saturating the pipe. And that was really my goal. It's like, if I put this cluster in place, I really want all these 10 gigs to be able to saturate it, even if I can't do it. But my concern was the CPU level. This is something we haven't seen anything there. So yeah, that's how we get that. With a regular node from PSC, we get like 450 megabytes per second on a single node. And in MapR, you can actually configure all your nodes in the cluster as NFS gateways. So you can actually like have an enormous amount of throughput on your NFS. But there's probably other constraints in there that I don't know of because we simply haven't done it. We have a subset of nodes for NFS. But when we started like 4 years, is it 4 years? No, it's 4 years ago we started with MapR. It's been a while. we tried NFS and we got like horrible performance. And I was like, what are we doing wrong? And then I realized that now, after we actually got it running with good performance, that I probably 4 years ago put an NFS node on the side that was not a member of the cluster, and then pushed data in that way. And that was very ineffective. I didn't really know what I was doing. So, but you know, we have a lot of help from these guys. They have a few interesting people at MapR, and so does Claudia, by the way. I don't want to be too MapR-ish here, but I mean, Srivas, who is the CTO there, he came from the Android file system, and they use their proprietary file system on these boxes because he knows how to get the performance. It's basically a database and a disk, which a lot of people have been doing on disks. But he's really good at that piece, right? And he came from Google and he was doing search there. So he also sold some company to NetApp. So this, you know, he knows what he's doing on the disk side, and he knows what he's doing with the distributed file system. So, you know, that's kind of a key piece for us. It's who's the people behind it. I mean, the CTO for Cloudera obviously that they have a whole bunch of committers into the open source of it. They know what they're doing on the inside. So I don't want to be too involved. But yeah, it has been. Ted Dunning is another good guy at MapR. He recently published his book for some enter book on machine learning, which is, you know, you can have your opinions about Hadoop, but it's a starting point, right? From what we see in the advertising space, I would really love more DSPs to get answers from real machine learning because, you know, it's kind of needed. And I see a lot of graph data engines, but we need a little bit more deeper learning to be talking about it. But yeah, so actually, when we talk about like MapR, I think Yarn is the next thing that we're really interested in as well. So that is actually like now your file system becomes like a separate piece, right? So you know, in terms of HDFS, you have your HDFS, and then you know, in our case we have the MapR, and then you have Hadoop more like a library for the MapReduce piece, and then you know all the applications that we're seeing on top of this with Spark Shark is really getting me quite excited about this and what it's going to show. So I actually think that we can get good performance numbers out of these systems almost real time next time. But the disk always scares me. It's like, you know, if I see a disk that I need, it's like I don't really want it. It's like you know, we're a RAM game. It's like everything we do is in RAM. So you know, most of the I basically told the guys that deliver our services, like, just put an SDHC card in there that I can boot from I'm good. And that's, you know, we did it actually on the latest PSSC nodes. We're actually using that DOM that goes onto the SATA port. So it has the OS, and then all the drives are just space for data, which is, you know. Yeah, so, you know, it depends on how good your networking team is. But yeah, you can. But getting that robust and really reliable requires that you have a really good network. And I mean, we do, but mostly in our serving pods, right? That's where we over-provision a lot of network, because all the data that's coming out is coming out with UDP multicast in protocol buffers. So we have like gazillions of these just coming all the time, right? And you know, a few switches just think it looks like an attack and will shut down, right? But yeah, I mean, for these kind of smaller situations where we have our Hadoop cluster and stuff, we don't over-provision the network in the server.
Okay, we just got time for one more question, so if anyone wants to ask, please go ahead.
Are you posting the slides, or are they up already?
I'll get the slides over, so he'll put them onto the site. So yeah, there's some references in there that you can use for a lot of the stuff that I talked about. So if somebody's doing more developments, come out.
How did you come up with the 80 millisecond time?
How
did you get to like the 80 millisecond time frame for your
networking and stuff? That's in the secret sauce. No, it's basically.
You want to repeat for people back there?
Huh? Oh, okay. So he's like, how can you do 80 milliseconds? And this is measured from the basically from the user coming in. We're taking the request, doing the auction to all the bidders, which is like 100 of them on a single request, and then serving that back to the user. So it is a pretty tight span, but we actually go and encourage all the people that bid on our platform to not be more than 20 milliseconds away. So, you know, we also co-lo very close to Amazon, so you can find like an Amazon space that you can use to connect to us as well. But, you know, Amazon is not the right place to run this type of auction because you have no latency guarantees inside of Amazon. We've done it. It's horrible. It goes up and down depending on who's on your host. And then you go like, oh, I'm just going to take the whole host, and even that is a bad idea. So yeah, we did a lot of tricks on the networking. So we also did a lot of tricks on the serving side. So I usually talk about rack affinity, where you keep the latency low because you don't have to traverse multiple network components, and also that helps you with the average load on your network as well. So now you don't traverse everywhere with everything. So you know, we have these microservers that we use. And you know, network is going where it should go, which is if you look at Intel's Photonics, which gives you a 3.2 terabit fiber, they're not done yet, but it gives you that kind of range. It's actually pretty similar to what I'm always looking for, which is like in that range for a bunch of servers. So we actually have like, in the back of that microserver, we actually have a three-dimensional torso that the things are connected to. And that torso has a 3.3 terabit backplane. So we make sure that the mappings inside of the torso is what we want them to be. And then, you know, the whole stack will fit in that torso. So that's how we keep our internal down. And then we measure, like, I mean, you know, there's an amazing number of things you can do with these speed up. So, yeah.
Hi, thank you. I don't know a lot about Zookeeper, but I've learned a lot tonight. Thank you very much. But I have a question which relates to a lot of what we've been talking about has been in the context of like within a single data center. And at the end, you were talking about how if you're going to be going across the WAN between data centers, you might want to use observers.
Yeah.
Is Zookeeper an appropriate tool if you did want to use observers in order to have like an HA type setup where you could potentially have an entire data center down? You didn't want one to be like the master data center necessarily and just use observers. Is Zookeeper still the right tool for the job? Or in that scenario, should my company be looking at different?
So you notice that I stumbled on that one.
What?
So I'm like 50-50. Zookeeper is probably like a reasonable solution. I think actually Paxos would be a better sync mechanism, but that would require me. I would be probably going to try it out. Would be my guess, but it is not like 100% obvious. If you were looking for me to be the guy that has already done it, I'm not. So keeping multiple data centers in sync is still kind of a task, and we're actually kind of fortunate. There's very, very few things that we need to have between data centers in sync. So I think a lot of systems have their own methodology of knowing that there's a cluster in the other end. They don't necessarily know, they have like a master definition inside that they can connect to, but they don't actually have a complete cluster set up. So that we are using that in a few systems, but we didn't develop that ourselves. There's other systems that sort of do that. I think that's probably a good question from my board, because they do replication between data centers. But I'm pretty sure they're not using Zookeeper. They're using their own thing.
Okay, thank you guys for coming tonight. Thank you, Jan, for this.
All right. Yeah, so if you use like an SA or something like that, or those things are horrible with like any measurement unloaded there. So Cisco is not they do a good job, but they do it like slow.